Hey everybody, welcome back to the Rust Review. I'm Brandon Conkle, and this channel, Deterministic, is where I try to find ways to embrace more determinism and predictability in our programming. Today I am joined by Alex Keliris. Thank you,
Hi,
Alex,
everyone.
for joining me. Hi.
Thank you, Brandon. Pleasure to be back.
So I've got Alex Keliris at Birdsite there. Birdsite is the Mastodon lingo for Twitter now. Twitter is the service that must not be named. I've been jumping into Fastodon, which is a Mastodon instance centered around open source, and actually really liking the activity. It feels kind of like early days on Twitter. I was part of Twitter early on when it first started out, and I've been enjoying it.
Oh, interesting. This is the one thing that stopped me from trying Mastodon at the moment is picking the server. So maybe I'll follow you and I'll join you there.
You can always pay like $6 a month and have your own hosted instance. That's one of the cool things about it.
Yeah, that's true.
So there have been some pretty cool articles this time, and I'm pretty excited about the first one that I will introduce here. The viral secure programming language that's taking over tech. Wired, the venerable and probably one of the most important tech news outlets in our recent internet history here, has taken on Rust and had some pretty exciting things to say about it. They posted this big story last week. It sings the praises of Rust, apparently due to its recent adoption in the Linux kernel. They present Rust as a viral language, citing Dave Kleedermacher, the vice president of engineering. He's the head of engineering for Android security and privacy, and he's the one who coined the viral terminology there, which is kind of funny to me.
I wonder what, like, viral amongst systems programmers, or well, I guess it is a bit viral actually amongst web developers like us.
I think it's got a lot of crossover. It's viral across many different categories, I think, but it's been capturing, systems programmers. It's been capturing web developers. It's seen adoption in the Linux kernel, which I think is a testament to how popular it's become,
Right.
but also in game development and things like that. It's got a lot of crossover because it takes this low level approach and gives it kind of high level ease of use and stability.
Right.
The article does a pretty great job, I think, of highlighting the safety of Rust. It describes it as goof-proof, which I thought was funny, and says it makes it impossible to create the most common types of exploitable security vulnerabilities. They say it could make a huge difference in the daily patch parade, which is interesting to me because it is definitely every day you hear about security vulnerabilities and new holes that need to be patched that are high security, high criticality. So I kind of share its optimism that the safety that Rust brings kind of built in inherently really could make a difference in the day-to-day view or the stability of software.
Definitely. I think there's a lot of focus on the memory safety compared to C and C++. But for me, coming from a garbage collected language, that wasn't such a problem. I suppose there still were memory leaks, there still were garbage collection issues. For me, the exciting part is more in the type safety, more so than the memory safety, but that's just because of my background, I suppose. So it's interesting. This article, I think, goes really into the memory safe, which is pretty huge because to get memory safe and high performance is, I actually thought it was like fundamentally impossible.
Yeah, I think a lot of people did. And I think that's the thing right there, because we have had languages that are more memory safe, higher level languages. I think Java is considered memory safe, but there's always been a performance hit, and usually a pretty significant performance hit. And the fact that Rust is able to achieve what we're used to in those higher level languages without the performance hit in most cases is astounding. I think that's
the right word. Astounding. It really is.
I've seen some criticism about the recent introduction to the Linux kernel, though, especially because it's not really bringing a whole lot of benefit yet. They are specifically introducing it to drivers in the Linux kernel first off here. So it's kind of on the edge, on the peripheral, but I think that makes sense. It's going to be a pretty monumental effort to move Rust further and further into the kernel. But the
Yeah,
criticism was,
that's what I was going to ask you, because I've been trying to understand. I've heard on the grapevine there are criticisms, but I've not understood them. So I'd be interested to hear, to understand that.
yeah, the idea is that the most of the code in the Linux kernel right now is not designed with the same kind of memory model that Rust uses, and Rust
Interesting.
has to interact with that code in order to do things with the kernel right now. So yes, you might have the level of memory safety that you see when you're interacting with drivers now, because your driver can be written in Rust, but it still has to interact with the generally unsafe code in the kernel. And and this article does a really good job of describing why that code is so problematic at times. They talk about a recent, like they bring up things like the Heartbleed vulnerability and things like that, but just recently there was a bug in OpenSSL that could have been saved from being used in a memory safe language, and this is after they've had great efforts to try to reduce these memory safe vulnerabilities in OpenSSL. And these are seasoned contributors. These are not newbies. These are people who've been working with tools like OpenSSL for a while. And for them to still see high security vulnerabilities like this it's telling. It shows how hard it can be in a system like C++.
Right.
The quote that they have from Dan Lorink here, it felt really compelling to me. It was that there are just limits to how much telling people to try harder can actually work. So at some point you need a better system. And I think that's a compelling point, because Rust could be that better system. This could be what actually forces people to do better, because the compiler won't let them mess up.
Exactly. That's what I love, is that it's not on me to do better. It's just telling me the right way that I'm doing it wrong.
Yeah. The article does have some shortcomings, I think. It talks about a calendar program as an analogy for memory safety, and the kind of situations that it brings up, like, requesting November the 42nd, or you've deleted all your entries in October and now you try to access them again. Like, for an actual real world calendar app to make those kind of mistakes, it would have to be atrociously badly developed with no input validation whatsoever. So it's kind of an awkward example, I think.
Yeah, because it's not like those are logic problems, like core application problems. They're not bugs with the machinery of the runtime. And I guess there's not really an analogy for that. Well, at least not that I can think of.
I think it would definitely be hard to put into words for non-programmers, but
yeah,
like I said, the fact that OpenSSL is still seeing bugs related to memory safety is shows how difficult it can be if you don't have a system like this.
There is I think it's called Rust LS or Rust TLS. I can't remember exactly, which is basically the Rust implementation of OpenSSL. And I don't know. I guess I imagine that is completely avoiding all of these problems, unless they use unsafe for some reason.
The way that they end the article, I think, is maybe a little bit too dramatic, tying Rust to things like cyber attacks on the United States and saying how much of that threat is on the back of memory safety vulnerabilities. But I mean, they have a point. How much of it is? How much would a memory safe language really help improve that kind of situation? It seems feasible.
I actually don't know. That's just, are cyber attacks mostly memory related, attacking memory vulnerabilities?
I've definitely seen reports from Google and Microsoft, and I've heard that this trend holds true along a wide variety of projects, that 50% of security vulnerabilities are down to memory safety issues. So a good half of the exploits that are out there are because of this memory safety problem. And it's because in languages like C and C++, you can get into situations where a crash can leak memory handles. It can leak things that exploiters need to grab hold of to take control or run privileged commands and things like that. So we haven't seen that in the languages that we've worked in. Our crashes are generally memory safe, but that's not always the case. It's really exciting to see Wired covering this. It's exciting to see it make it into the Linux kernel. I think the viral description there is apt, because it didn't necessarily have to make it into the Linux kernel. It's really the strength of the community and the momentum behind it that has brought it there. And so it's cool to see it gaining mainstream attention like this.
Definitely. And I don't know if this is one of the criticisms leveraged at Rust for getting into Linux, but I imagine some people would think it's sort of the trendy, shiny new thing. How all developers seem to love the shiny, the new
I
things.
have no idea what you're talking about. No, you're right. It's a constant.
But I hope that Rust, this decision is extremely well motivated, above and beyond anything like wanting the new hotness. It's more that it's just helping everyone to do better.
Yeah, it's already been around for 12 years now. So
Right,
I hope
exactly.
that that's a good sign that it will endure for the ages.
Definitely. I'm certainly gambling on that.
Yes. All right. So I'm about to switch over to your screen, Alex.
Thank you. This is a really interesting find, a great little project. I've been keeping a little file open that I just jot down notes in to say these are the crates I'm currently interested in using, or these are the common crates I use in nearly every project. But this goes a step further, and it's just a really decent curated guide to the different crates that are available. I don't want to use the word problem, but one thing with Rust, this first paragraph explains it. Rust has a fairly small standard library. It's not a batteries included language by any means. Coming from Python, even Go, and Go has a somewhat limited standard library, but Go has like a really decent web server out of the box.
It actually has surprisingly a good standard library, in my opinion.
I think Rust actually does better than Go in the having hash maps, hash sets. With Rust has some more collections that Go doesn't have in the standard library. Like there's no set, which for some reason in Go, which is tripped me up.
Yeah,
a few times.
I feel like Rust brings a little bit more consistency across the APIs in their standard library too. Go seems to have some scattered approaches here and there, and it's not always consistent with other pieces. But Rust does better at that, I think.
It's very true. I also found it a bit strange, certainly the async await system, where the language, I know we've spoken about this briefly before, but the language has syntactic support for this feature, but then it expects a runtime, a user-land runtime, a non-standard library runtime to actually execute them, execute the features. So it's a really interesting approach.
Yeah, and I like that it allows for different implementations for different use cases. Like Tokyo may not be the best for your particular use case, but this library over here that's perfect for embedded systems might be right up what you're looking for.
Yeah, it does. It's really trying to hit a sweet spot right there where it has the primitives needed to build up all of these abstractions, but it doesn't necessarily need to maintain them itself, which is good because like changing the standard library is very difficult, whereas changing a third-party library is more straightforward.
I think the author of this guide here, the Blessed Guide, it comes from an engineer named Nico Burns, actually out of London. I think he's got a really good point here, though, that it does make it hard to know which packages to trust, which ones are the most reliable.
Yeah. Absolutely, and I suffer from this myself. If I go away from Rust for say 2 months and I come back and I think, is my error handling still good? Is the library even maintained still? A great one that tripped me up recently is I've been using the .env crate for the longest time. I'm sure you use that crate, but now it's considered it's not maintained. I don't think anymore. So you now need to know what is a maintained version of .env. This is why I find this list really valuable. Even as a sort of somewhat seasoned Rust developer, I'm learning new things looking at this. So
yeah, same here. There were a lot of familiar ones on here, obviously, and I think most of us will recognize things like Rust Up and Clippy in Rust format. But there were definitely some crates that weren't familiar to me, like Cargo Edit there in the managing dependencies section. I'm used to adding dependencies with Node, really with the CLI tool, and Cargo never had that. You just added it to the your cargo.toml file. But this kind of gives you that more familiar add and remove interface, and I thought that was cool.
I believe this one in particular is so popular that I think it's part of Cargo now.
Oh,
I
is it?
can't
I did not
actually
realize.
remember. But I think there was an effort to move this into cargo itself because it is so good to just do cargo add. I do it. I use this all the time. I love it. My bash history tells me when I'm starting to do cargo edit, I can just, if whenever I start a new project, I can just go through my bash history and just add them all.
Cargo deny was something that was kind of interesting to me also because
Mm.
there are a lot of organizations that have licenses that are incompatible with other licenses, or there might be
Oh,
crates
interesting.
that have specific vulnerabilities or things that you want to avoid. And so cargo deny allows you to set policies and block packages with certain licenses or things like that to make sure that your dependencies are consistent with your licensing model and your security model.
Interesting. I've not used that one. So that one is cargo deny that does all.
Yeah, that's right.
Hmm. I've used cargo edit, cargo audit for running in CI. It's brilliant. Just have a cron job in GitHub Actions to run audit every day or however active your code base is. I've not used this either, cargo next test. I'm curious to try this.
That one I've been seeing get a lot of attention lately. I've started
Mm.
using it in my newer packages. It's really fast. It uses a better concurrent model for running it based on Tokyo, and
Oh, fascinating.
it's pretty great. I think I had an article from the creator of it a show or two ago.
Oh, okay, interesting. Some great ones, some classic. This one actually, I would like to start using in my Spotify project, just for automating the release process.
Oh
I've cobbled
yeah,
together myself, but this probably it would be nice to simplify my CI by using this.
I've definitely missed the kind of conveniences that tools and Node have for that.
Yeah. So I've got a little list of a few of. I haven't fully automated the release process in my Spotify project, so I have to still like bump the versions, do some
Yep.
little bits here and there, and then I push a tag, and then it actually builds everything and publishes it. But yeah, that's a really good one to look at.
If you scroll up
Yeah,
just a little bit, cargo expand, actually seeing what macros expand to, that seemed really neat. I haven't used that yet, but I feel like I've needed it in the past.
yeah. I tried to use this to understand how Actix works, and when you with Actix you have your macro on top of your procedural macro on your handlers, and I was like, what actually is this doing? How does it work? And this, even though unwinding that code is actually still not super easy. It's a really
Macros can definitely throw you for a loop.
yeah.
There's also cargo show ASM on here, which is similar, but letting you view the
Oh
assembly code that gets generated so that you can try to spot optimizations if you're a really cool hand optimized assembly hacker.
gosh, yeah. I've not. I've actually wondered how you do that. How do you see the assembly? I should try this just for curiosity. Not again.
Yeah,
I don't think I'd even get a hello world. I wouldn't understand the assembly for that.
it'd be a great way to learn, though.
Yeah, true. All right, and then it moves on to all these classic crates that you reach for all the time. Um, this is quite good. It calls out that it's not clear which one to use. It does a great job of actually explaining with date and times whether you want to use time or use chrono. I've always used chrono. I've never actually used time, but I definitely like that this one might be simpler. So this is such a great list. It really calls out the trade-offs and why things have been chosen. This is
The
my
slog crate in
go-to.
here, I
Oh
hadn't
yeah,
heard about. Sorry, the anyhow. Oh man, anyhow is like ubiquitous. But you said you've moved to the color IR one recently, right?
exactly. That's what I was going to say. The only anyhow is fantastic. I've always used it. Now I've just started experimenting with color IR because it just looks really nice when you get errors and panics in the code. But like it says, it's really good if you're going to be showing that output to end users. So for the most part, if I'm building a web server, anyhow would be great.
Anyhow, and this error it works together with pretty smoothly also.
This is fantastic crate. It's so clever. For you create your enum of error types, derive this error on it, and then you get super nice errors, error handling, really high quality error handling in your app.
Yeah, slog. I've used structured logging in other languages before, but hadn't gone looking for one in Rest yet. So that's definitely something that I'll pull into my stack really soon, I think.
Yeah, every time I've used tracing for some time now since reading Zero to Prod, I think probably back in 2020. But I always think I'm not structuring my logs at all. I'm just basically writing a string and saying this thing is happening.
Yeah.
Um, and I've looked at slog before, but I should take a look again.
If you go down a little bit further, the FFI interop libraries were really fascinating to me. I didn't realize that there was this much support out there for embedding in different languages. I knew it was good for embedding in different languages, but I didn't realize all the tools that were out there. So this is really inspiring, I think.
Definitely, and generating the binding is just fantastic. I've actually got a library in Zig created in the Zig programming language. I don't know if you've come across that. And I would love to use it, the library in Rust, and I was trying to figure out if I could create a C header file from Zig, use this bindgen crate or C bindgen to generate. No, it'd be bindgen to generate Rust bindings to the C header. But yeah, this is fantastic. This is like magic.
That's awesome. And I know I mentioned Pio3 on the last episode, talking about an interop bug with the one of the Python features for zero copy interactions, and Pio3 apparently does a pretty good job of modeling around that. And yeah, cool tools out there.
And this one, Nappy, this has been used by Prisma, I believe, the Prisma ORM, which I think the core is written in Rust, and then they expose Node.js bindings through this Nappy tool. I've used Neon before. I've not actually tried Nappy yet, but apparently
I didn't realize that Neon was slower, so that call out was helpful there.
Yeah, that is interesting. The thing when I did write my JS code, my Rust code that was calling from Node, a native Node implementation, just JavaScript, was actually faster. But,
wow!
So that was interesting because there's some overhead, I guess.
Yeah. All right, I've got one more towards the bottom to highlight. But anything else that you come across?
IO-Uring or Uring. This is really interesting.
That's exactly what I was going to call out. Yes. Oh. The Glomio library with it's this cooperative thread per core approach when you've got, I assume, really CPU intensive workloads. But it exposes it through that familiar async await interface without using helper threads. Apparently, it used to use helper threads. I don't know. It just sounds like a really interesting approach.
Definitely. And I think, I can't remember what the syscall to Linux is for suspended. Is it epoll? Maybe something like that.
Good question.
Where I think this is much more efficient for asynchronous workflows at the kernel level. And so this feature of the kernel, it'll be awesome once it's more stable. Well, the Rust bindings to it are more mature, so it might just improve. I could be off, but it might improve performance for web servers.
That would definitely be interesting. I know web servers have a lot of I/O blocking too.
Yeah.
But yeah, I'd love to understand more the pros and cons, the trade-offs.
I know you've been using some tungstenite recently. I actually had a question for you. Are you using Tokyo tungstenite in your GraphQL server?
Yeah, using Tokyo tungstenite specifically just for the integration testing piece. So connecting as a client to my WebSockets server process. So I haven't used it for the server side of it, but it's been great for testing things out in the integrations. And
are you using the GraphQL subscriptions, the GraphQL library? Does async GraphQL implement the WebSocket for you?
I believe it does. It definitely has the subscriptions feature, and I believe it uses WebSockets behind the scenes to achieve that. I'm not using it though because I like the full duplex push and pull model, and the GraphQL subscriptions are really more push. But that may have changed. I haven't looked at GraphQL subscriptions in a few years, so they may have changed that since then.
Yeah, The only other one I was going to mention was CORM, which I've been using SQLX for ages now, and it's
Oh,
my
it's
favorite.
awesome. Yeah.
I'd
But it
love to
is
try it.
limited in dynamic cases. So I've
Exactly. Yeah.
definitely loved CORM for
Have you?
like really highly dynamic APIs.
But yeah, that was it from this list that I wanted to call out. I think just generally all of these are great. Cross term, I use this in my Spotify TUI project. It's
Oh, yeah.
fantastic. Cross platform, so it works on Windows and Mac, Linux, brilliant.
Goes into some of the graphics and game development stuff down there. It calls out Bevy, which I really need to get started on Bevy. I've been intending
Oh,
to for a while.
so clever. Bevy's actually great for learning more about Rust generally because it teaches you things about like how to increase the speed of you can do things to make the compiler faster so your feedback loop is faster. And I've taken my learnings from that to my other projects. So because obviously the game is very heavy, so you want to be able to
Yeah.
compile it as quickly as possible. So there's loads of clever stuff in there. I'm definitely keeping an eye on the GUI stuff. Um, it's still not. It's still that Tori is probably my favorite approach to building web apps, but it's still using it's not using Electron. It's using the native operating system's web UI, which is much more lightweight, but
That's good.
still
Yeah.
running a JavaScript engine.
I've done some work on Electron projects with dealing with WebRTC, screen sharing, and stuff like that. And Electron can get really heavy. It
Yeah,
includes the entirety of Chrome essentially inside
yeah.
it. For each application, it's a new copy of that. I know there's been some progress towards that in recent years, but it's still a pretty heavy platform.
Yeah, I think this is where this excels because it uses the system web view rather than the full-blown Chromium. So your actual your application's like 20 megabytes instead of 500 or whatever it is.
Nice. At the very
Yeah,
top of this, I'll close with this. The librs that they call out is another interesting place to go. It has basically programmatically sorted packages. He says sorting by number of downloads, but there's a variety of other metrics that you can use to kind of sort and group with. So that's another fun place to find packages with less of the human touch. They're not quite blessed.
yeah. I'm glad you mentioned that because actually that's probably my librs is my go-to for exploring crates generally. I use their search functionality. It's really good.
That's really nice. I've been doing crates.io, but looking through librs recently, I'm liking it a lot better. I think I'll switch over to it.
Yeah, yeah. Although there's still crates, like for example, I'm trying to hunt for a better way of doing my templating, and I'm trying to use librs for searching, but it's not coming up with. I think Reddit has actually helped me find crates that are better, interesting crates for my use case as another search tool. But certainly librs is great.
Nice. Oh yeah, I use Reddit a lot too to find articles for the show and things like that. The Reddit community around Rust is great. All right, so switching over to the next article I want to talk about. I've already talked about Rust 1.65 quite a bit because of the generic associated types. I just put out a video a couple of days ago diving in a little bit deeper because I betrayed the fact that I didn't quite understand them thoroughly enough in the last Rust review episode. So this was making up for that. But skipping past that, another really cool feature that hasn't got nearly as much attention is the let else statements that were introduced. I think 1.65 was just released like last week, right? Yeah. So
Yeah.
the let else statements here are similar to the ability to use pattern matching with if statements. So, you can do an if sum to pull the contents out of the option with the sum variant. If it's present, then you can pull the contents of it out. But then you can only use it in the context of that if block. So you've got that indented block, and that's the only place that you have access to the contents of that sum or the result or whatever. So this is a way to kind of flatten that out a little bit and also provide an automatic fallback value. So introducing pattern matching with the let assignment allows you to pull out your sums, pull out your OKs, whatever you need to provide a fallback default value, and then have access to these values outside of the scope of the block. So it's no longer has to be in an indented block.
I've been trying to understand, like doing a panic in the block to exit from it.
I wouldn't imagine that this is what you would do in day-to-day production programming. But I think what they're demonstrating is that you can circumvent control flow. You can kind of short circuit things with a break or a return or a panic, which can be really useful in certain cases.
Yeah, I've struggled to imagine where I would use this feature, but I could just not be understanding it. Or maybe I'll when I do come across it, I'll be thankful that this exists now.
I think I'll use it less with panic and more with something like a return. So if a negative case happens, then I can do an early return. Otherwise, I can just continue forward with the value that was in the positive case and not have to have that be nested in a indented if block.
Right.
That's a cool feature. It's small, like I was saying, but it's definitely looks like it'll introduce some more flattened control flows and make things a little bit less like we said back in the classic Node days, the pyramid of doom, where indent. So this will further help to avoid that.
Yeah.
All right, I'll kick it back over to you.
This one has me really excited. I think I've experimented with fuzzing in Rust before, but this this is the first time I actually came across this project, Bolero, which combines different fuzzing engines and approaches which have different unique trade-offs. So instead of writing, let's say you wanted to write some super robust code, you write a test harness for one engine and then a test harness for another engine, and then you have to invoke them separately. This Bolero is really clever in that it abstracts over these other alternate engines, fuzz testing engines, and lets you write one test harness and apply those different engines. But maybe we should talk first a bit more about fuzzing in general, why you would want to do it.
I know I touched on it a little bit in the last episode when I talked about prop testing specifically, and the author of that article kind of compared and contrasted the two by saying that fuzzing is generally a more long-term, really thorough kind of testing. He said it could even take up, weeks or months at times if you're really thoroughly fuzz testing something, whereas prop testing is intended to fit in your unit testing framework and is usually pretty tightly constrained timeframes to make it reasonable in that context. Does that line up with your perspective here?
Yes, and I suppose prop testing if we're manually writing a prop test, we'll do something like this, where we'd say, we're going to use some inputs, we'll hard code the inputs in here, run the test and assert something. And that would be the most basic property-based test. The confusing thing is there are libraries called prop test, which are actually generating those properties. They're fuzz testing, really. They're generating lots of input and then running against your assertions to see if the assertion holds up for a wide range of inputs.
And the idea is that it's taking assumptions that you've made based on the type and filling in actual values randomly generated to find where those assumptions break down, right?
Exactly. It's trying to reproduce real world inputs for that given type, and then checking that your code runs as expected. There's no unexpected panics, or the control flow is correct for all possible ranges. But with fuzzing, as you said, you could run it for months and you might simulate 200 years worth of usage. But the next level above this is proofs, which is so interesting. And this is
that's where you test with every possible input, right?
You prove that given every possible input, your code it works this specific way, the way you've specified. And that is super that is so powerful, and it results in a much higher level of quality in the software. And so now this Bolero framework for fuzz testing is now incorporating this project called Kani, which is this way of verifying your Rust code does what you say it does for all possible inputs, which is just mind blowing.
That's really cool. I hadn't heard about Kani before, but that is definitely interesting to me, especially in really mission critical context. Like talked about Volvo using Rust in cars a few times lately, but that's one place where I would feel like this would be really useful to just test every single case.
Absolutely. The only way of doing formal verification or proofs I thought was extremely difficult. And you would, because of that complexity, you would only do it for extremely high risk branches of code where people could literally die if there's a bug.
That's what I was thinking. Yeah.
Whereas this, I feel like this lowers the barrier to entry. Let's just skip ahead to the what the Kani integration looks like. So this would be if you wrote Kani from scratch, which is so nice. Like this is so good to see. It's basically the same as our prop test, and all we've done, our basic unit test above, all we've done is replaced it with this Kani call.
That's so smooth, yeah.
And now we also derive a macro on top of the test, and then when we run Kani, we'll get a really nice output. So let's just have a look. That is a normal fuzz test. So you can see the fuzz test is saying these are the values that are causing the failure. It's so clever. It generates tons of tests, and then it shrinks them down to say this is the cause of the failing test. But with Kani, it will just immediately I think what it probably does under the hood is it converts the symbols in your Rust code into some checking engine, some verification engine, and then somehow it proves that it proves this about the code. So in this example, there would be an out of bounds index, which you do need either. If we have a look at the source code, this is the function we're trying to test. We're trying to get an index for an array, and we've missed out the -1.
Yeah.
the classic off by 1 error.
And this is a case where, yes, Rust is really comprehensive. It can keep you from shooting yourself in the foot in a lot of ways, but your business logic is your own responsibility.
Exactly. And then to previously, like we could have thrown in an array and then an index, and we could have written 5 unit tests and all of them would pass, but actually there's lurking in here a value that would fail. And now fuzz testing would give us realistic usage, would simulate loads of usage of it, and it kind of gives us more confidence because we're covering more cases. But then to have a proof that this test would fail, it fails immediately when run through Kani, because it knows that this can produce bad input. And in Rust, doing this would cause a panic, so it'd be really bad.
That's the worst nightmare for a Rust developer, or any developer, really.
Yeah, exactly. And I'm just amazed at how good this looks. Like you just run your tests
so easy
like
to work with. Yeah.
Yeah. So I just got to add this. I've actually got cases. These out of bounds problems happened to me in my Spotify project, where I've got, say, a list of songs in your Spotify playlist, and the user is using keyboard inputs, and let's say I want to wrap the user around. When they get to the bottom of the list, I want them to jump back to the top, and that involves some super basic index arithmetic or something. That might not be the best example, but I've tried using fuzzing to check if my arithmetic is correct. But now I could use Kani to just say, yeah, it's 100% correct.
Check all the cases. Yeah.
So
I wonder how long it
exciting.
would take to do that.
Here's an example of that. Proving this statement was very quick.
That's very quick. Yeah. That's really cool.
maybe if you had hundreds of these, it would become problematic. But maybe there's some caching that can be done, so you don't. Whenever you run your tests, you're not having to prove the same thing over and over.
Yeah. Oh, that's true. You can have validated states.
So I'm definitely going to try this out in one of my Rust projects. I'm really excited by this one.
I am too now. This is really interesting. All right, so I'll take on the next article. Nicholas Cameron, he's a principal Rust engineer for Microsoft, and I last featured his work on the very first episode of the Rust Review back in September.
Cool.
He's posted this new guide to error handling in Rust that introduces Rust language features for handling errors with guidance on how to use them and how to think about errors. And we've talked before about how the result and the way the syntactic sugar around result and OK and everything is one of our favorite features about Rust,
Absolutely.
the well-controlled error handling it provides.
Absolutely.
If you are not familiar with all the different ways of handling errors or the kind of philosophy around approaching errors, this is definitely a really useful guide. It's just getting started. It was just posted, November 8th, so a few days ago. So there are some sections that are missing, but will be filled in further as we go. But I hadn't looked into error handling in FFI situations at all, so that was new to me.
Ooh.
And
yeah, it's not something I know much about either.
Things like C errors or OS errors, definitely interesting stuff there. It goes into the Rust ecosystem, the crates, like we've mentioned. I hadn't heard of Snafu before, so that's going to be one that I'll check out soon. Talks about IR and that it's a fork of anyhow, which I think you had mentioned to me before, but I had forgotten.
Yes.
But then it also goes into how the approach, the strategy, the philosophy, how to think about errors, whether it's an internal or an external error, whether it's expected or unexpected, recoverable versus unrecoverable. We've been talking within Formidable a little bit around error handling in TypeScript and languages that use throw a lot to kind of circumvent control flow, and people can get into the habit of using exceptions for control flow. But I like making that distinction, and I like how Rust really places a lot of emphasis on that distinction.
Absolutely. I think that is the right way of doing it, where we make a distinction between recoverable errors, which we model as the result enum, or unrecoverable errors, which would be a panic. But in TypeScript or JavaScript, we just have throw, which is, in my mind, that's closer to a panic. But then you can recover from it with a try-catch. So it's like a weird mix.
Yeah, the layers of bubbling that you have to be aware of are definitely interesting. With Rust, yes, you have the bubbling essentially with the question mark operator, but you can constrain the type of errors that can bubble. You can make sure that you've enumerated everything that could possibly come out. Although crates like anyhow kind of limit the effectiveness of that a little bit, because anyhow or this error kind of allows you to say it could be any error, but internally you'll often constrain that a little bit further and look for specific errors and make sure, like with the GraphQL libraries that I like to work with, it makes sure that the error returned can be converted into a GraphQL result, or for HTTP libraries, an HTTP error result. So those kind of constraints are really helpful. This case studies tab is one of those that's coming soon, but he links out to a couple of other resources, and just generally found that a really great overview, and can't wait to see it grow.
I'll have to go through this. I'm always interested in reading more and improving error handling, because it's such a huge part of every code base. And when you get it wrong, it's just a nightmare. I'd say in Rust, it's hard to get it wrong because it's all in the types. You're forced to handle the error. You need to unbox the result to deal to, so you can get what you're after. And I mean,
it still takes some thoughtfulness, though, I think, to craft your types and your variant cases in a way that's easy to work with and captures everything that you can recover from. I don't know. It definitely still takes some work, but you're right. Rest makes it easy.
One thing I'd be curious if this speaks about is my approach has been to, when I write something new, I will just use unwrap everywhere. Just use the unwrap keyword, and then once my thing is working, I'll go over it and handle the error correctly.
That's pretty smart, actually. I hadn't thought of that. I was thinking that I would use unwrap and then forget about it, but you're right. You can just do a search and find all the cases of unwrap to make sure you've handled them correctly.
I try. It's a little bit dangerous doing things that way, but I try and I add a to-do comment, and I wonder if Clippy can even force you to never do unwrap or something. If there's a lint rule to say
I'll bet it could.
You can't merge this because there's an unwrap.
All right. Well, I'll throw it over to you for our next article here.
This is really fascinating as well. This is a great example of WebAssembly on the server, which I think is a really, it's going to be a huge driver for innovation for the backend generally. Where we've always thought of WebAssembly would be running inside a browser, which it does. It turns out WebAssembly is also it's a super lightweight containerized runtime that could then be deployed anywhere. And so there's this new company called Shuttle RS is the website.
Yeah, I think we've talked about it a little bit in previous episodes, but yeah. I'm excited about it too.
They make a compelling point, which has been spoken about before, that containers are an amazing abstraction. They really do. They make for a really consistent runtime across hardware architectures. But one of the potential, I don't want to say again, I don't want to use the word problem, but containers
trade-off, maybe?
Yeah, I suppose it's a trade-off. The containers are so general that you can literally, they're good for running anything in. Whereas if we maybe constrain what can be run in the container, we can regain some of the heavy, because they're so general, they can be considered heavyweight. And maybe if we constrain some of what they can do, we can make them lighter and faster.
It definitely makes a lot of sense. It's kind of funny to me, though. I've been in the industry for a long time. My earlier projects, some of them were on actual physical colos. And so to re-image our server operating system or something like that, to clean things out or update things, I had to literally go out to the colo, the data center in Dallas, and go into the big server center rooms with the huge fans going so loud that you had to shout at each other and pull the servers and replace the hard drive that failed in the RAID array and stuff like that. And then we had VMs. We had things like VMware, and that definitely made things a lot better. But I remember back when I was working with Fidelity Investments, they were really heavily VM users. To provision a new service, it would take months. They had such a backlog, and it was such a complicated process to get things together just the right way. I'm sure things have improved. That was, 15 years ago. But back then, it took quite a while to get a new VMware instance up and running. And so then containers came along, and they made things smaller. The runtimes were more efficient, like they were talking about there. It was a lot easier to provision your specialized runtime environment with all the dependencies and libraries that you needed. But I love that we're still whittling it down even further and realizing, okay, you really don't even need all of that. This new approach with serverless approaches has been really drastically changing the landscape. But I like the Shuttle's approach. In this article, they have a little bit of justification about why they went to WebAssembly, and it's really exciting what they're able to achieve.
Absolutely. I think, you provided the context of we just had hardware, then we had VMs to help abstract over some of that hardware, but they were very heavy, very slow. Containers
And you had to
came
use
along.
tools like Puppet and
Yeah,
things to manage the configuration. I did a lot of work in Puppet and similar tools. Chef is another big one to try to keep those VMs up to date. You couldn't just cut a new image.
yeah. And then one of the problems I have now, every time I want to deploy a new Rust web server or I need to Dockerize my Rust code, it is so painful how slow it is to build Rust within the container, especially on a low-powered CI machine. Having to download the full Rust toolchain, which is many gigabytes,
Yeah.
break up your Docker file into layers so you can try and get some caching working. It's just, I think one of the big problems with containers is, as the article says, a cache miss literally just means rebuilding everything. And that's a lot of work.
Yes.
So
and Rust is not known for rapid
no,
compile times.
exactly. It's starting off from a slope. Even on super decent hardware, it's still not the fastest thing in the world. Without any abstractions, virtualization, and then adding the virtualization, which, as it says here, virtualization is just really, it's just abstracting the I/O, what's happening at the I/O level. So then, given how slow, given that containers are amazing, they have some problems because they're so general. What the question, I feel like this article is saying, but what if we were to just specialize a runtime for web servers? Would that, especially, so for example with Rust, would that mean we can take away all of your, instead of rebuilding your code plus all your dependencies for every deploy, what if we just rebuild your code and we have the dependencies already running somewhere or already compiled somewhere?
Compiled and just ready for you to link to, essentially. Yeah.
Exactly. And to skip ahead a little bit, WebAssembly.
I like this tweet that they highlight there from Solomon Hykes. He's one of the co-founders of Docker. Just the fact that he's so excited about Wasm. He says they wouldn't have even needed to create Docker if it was around back then. That was a cool quote to me.
Definitely, certainly something we see cited a lot with the excitement around WebAssembly on the server, as it provides such a powerful, incredibly lightweight abstraction over the system level I/O, and then Shuttle themselves are announcing a new service. Just to skip through all of this, called Shuttle Next, which is I've signed up for it just to see what it's like, but it's still in a closed beta at the moment. And the premise is we take our Rust code, which might look like this, where we have an Axum router, hyper server. Instead of what Rust does at the moment is it will compile all of this from scratch unless there's incremental builds available, which can't be done easily inside a container. And then they've optimized this massively, so it's incredibly incremental, and essentially your code would become something looking like this, where all of your big dependencies, like your ORM or your database connection library, your web server, it's already been built and deployed somewhere in their cloud and isolated within a Wasm runtime, and then we can just compile our tiny snippet of code, which would be, they say, is effectively 100 times smaller, and because it's so much smaller, it can be deployed insanely fast.
Amazingly fast, yeah. Less than a second. Coming from we're projects that we've been on with build times that can take upwards of an hour.
Absolutely, just painfully slow. And even on my hobby projects, where I'll have say web server. I had an Actix web server with, say, 10 routes, and it was taking 30 minutes to build in GitHub
Oh my!
Actions within a
Wow.
Docker image. Yeah.
So they have things, really common things included like Tokyo, Hyper, SQLX.
Yeah.
But one question I had was they don't have an ORM right now, for example, and so
Okay.
one of the issues on Shuttle's issue tracker right now is support for CORM, which we just talked about a moment ago.
Oh, is it interesting?
Does that mean you literally can't use it, or does that mean if they provided CORM in the runtime, you wouldn't have to build it? Is that the distinction, or can you really
That's
not
a
even
good
use
question. I imagine you can't use it because it doesn't compile to WebAssembly.
Oh, that's a good point.
But I wonder if it does compile to WebAssembly, you can just use it. I'm not sure in that particular case whether if they are only going to cache, they're going to have to support things that are cacheable in their system. Or you can just bring your own WebAssembly stuff, but it's included. That does need to be built every time. I'm not sure how it works.
Definitely interesting. I definitely want to dig in and find out more about it. One of the other things that I was curious about was how open Shuttle is. So we're seeing the walled gardens collapse all around us. Things like Twitter and Facebook that is walled social media gardens, and just a lot of these proprietary things. You see how fragile they can be over a long period of time, and open solutions generally last longer and you can do more with. So I was curious about Shuttle. Is it just a closed proprietary thing? But no, they actually are quite open. They've licensed their entire platform under Apache 2.0, and they talk about how you can self-host. I wasn't able to find a self-hosting guide. They're not like going out of their way to make it really easy for you to not pay them, but it's possible, and that's cool to me.
I didn't realize that. I imagined that I was going to say probably one of the trade-offs of this is that the WASM runtime that does all this clever stuff is proprietary, but that's very cool if they are open sourcing a WASM host or runtime, I guess, that you can then deploy into. I'm not sure how it works. Yeah,
that's what it looked like. I jumped into their GitHub repo. I didn't have a lot of time to dig into it, but it looks like it's all there. It looks like you could literally host your own Shuttle on your own server, which I would be very interested in.
Absolutely. And I think you can pack a lot of WASM, you could pack a lot of code into a host. And you could do this anyway with Docker. But if WASM is really that much more lightweight, more resource friendly, I'm imagining I could just have one big server with many services in it, and I'm just packing it full of things, and I've got a really simple, a much more simple deployment target rather than, say, Kubernetes, where I have to manage a lot of complexity.
Yep, Kubernetes is great, but it is definitely complex. There's a lot of moving parts.
Yeah.
But then so are proprietary walled garden environments like AWS.
Absolutely. Yeah.
So much complexity there.
But yeah, so I think the takeaway from here is that I think it's super exciting to see where WASM is going to take back-end development. I really think it's going to be a revolution, so to speak.
Yeah, I've seen some doubters out there, generally coming from the anti-JavaScript crowd, that feel like WebAssembly is not really a solid base to build all this on, and I would push back against that. I think especially the efforts that big companies like Google have put into the V8 runtime and different ways of optimizing JavaScript, they've really made it a extremely performant for what it is. And the WebAssembly target, I think, takes that a lot further in ways that will be really useful in a lot of different contexts, not just backend, not just running in the browser. I think we'll see new applications for this every day. I think it really is the new assembly.
Yeah.
All right. So last article today, I'm skipping one that I'll go ahead and link to in the show notes that actually brings up Zig. You mentioned Zig.
Oh, interesting.
But I'll add that in the show notes. But this one is the one that I'll close with.
Yeah.
This is from Adrian Taylor. He works on Chrome at Google, and he posted this article about an experiment that they ran using the base value type that represents a tree of arbitrary values. So kind of like the DOM node or something like that. And he talks about how safe this API is, but then he goes through and finds ways that he can break it. So he induces crashes in a few different ways and takes a look at them and sees, okay, are these safe crashes or are these exploitable crashes? And in most cases, like he said, the base value API is very safe. It's been very well tested. I think it actually is what they use in Chrome for the DOM nodes as kind of a foundation for all of that. But he is able to induce a unsafe use after free crash that is kind of confusing at first. He didn't even notice that it was not a controlled crash until he realized that this error message was a little funny. And so he added the address sanitizer and realized, oh, no, we've got a potentially exploitable use after free here, even in this really safe API. So right off the bat, that kind of illustrates the point that Wired was making in the first article that we talked about, that like you can put a whole lot of effort into making C++ safe, but you still find pitfalls.
Absolutely.
But he's saying that for the C++ environment, that's a pretty good score. But at what cost? So to get that, he had to debug a lot. He had to intuitively know that, oh, that's a use after free. That's going to be exploitable. And all of the checks that are in place, he talks about that's runtime overhead, because it's actually checking values at runtime. So you get a performance penalty there.
Oh.
The promise of Rust is that you can get the same kind of safety, the same kind of memory safety that we've talked about before, but without the performance penalty, because it's doing it at compile time rather than runtime. And it skips those runtime checks with the same amount of safety, which is really awesome. Absolutely.
This is the so-called zero cost abstraction that is just incredible.
They wondered, what if you took an API like base value and wrapped it in Rust and used FFI essentially to work with it? Would you get the benefits of those runtime checks without having to actually run them, with doing it at compile time instead? So
before we answer that, my intuition would be that the Rust wrapper wouldn't help. But anyway, we'll see.
The results are pretty interesting, actually. So he said, he asked the question, do those promises hold true even if you're wrapping pre-existing C++ code like this base value? And the answer is yes, he says. So he goes through and he gives the same examples, the same 4 cases that triggered crashes in the C++ code, and he triggers them again in Rust, or tries to. But in several cases, the type system of Rust prevented him from even getting to that point. So he said the first 3 cases didn't even compile. The compiler prevented him from making those mistakes in the first place.
Wow.
Which is awesome. Before you even tried to push it into the testing environment, you would know, oh, these cases are not safe. This is going to be a problem. One of the cases, they were able to use new types to even prevent the code from getting into a situation where the error was possible. So it's not even that it wouldn't compile. You didn't even get that far. It was just using the new types correctly to prevent mixing one type for another, prevented the whole class of errors entirely.
Smart.
And then the last case, they said, they were able to avoid it by using iterator pipelines instead. I'm trying to find that spot. I can't find it in the article, but they said doing it the way that you would idiomatically do it in C++ was, what was it? It was indexing into containers was the way that they were doing it. But that's not very idiomatic in Rust. In Rust, instead, you're going to use a pipeline of iterators. So the dot map, dot filter, things like that. That's more common, and it actually prevents the case that the C++ code was getting into in the first place. Definitely good scores when it comes to safety, but the performance boosts that they got out of avoiding those runtime checks was really kind of negligible. That was ultimately what they came away with was, yes, it is more safe. Yes, it does prevent these runtime checks, but no, it wasn't really that much of an improvement in terms of performance.
Yeah. I would have thought that would be a very good trade-off for this, though, that you'd be happy to accept that. That would be like best case scenario, I'd have thought, that safety with no performance impact.
Yeah, I agree. And they agreed too. They decided not to go any further with the base value type, but they are increasing their usage of Rust and starting to find other ways that you can get more bang out of introducing it to Chrome's code base.
Right.
I think that'll do it for us today. They had some really interesting articles. There were a bunch of articles that we left behind, articles that we had to skip. So definitely take a look at This Week in Rust. It just came out last night, probably morning time for those on the UK side. And packed with a whole bunch of great articles. There's so much activity going on in Rust right now that there's no way that you can cover all the stuff that's going on. And that's pretty exciting.
Absolutely. It really does feel like a proliferation of content, YouTube videos, your coverage is fantastic. It's great as a Rust user. I've been trying to look for this stuff since like 2017, listening to podcasts, but it's better than ever. There's always something on Hacker News I can read, or on Reddit. That's fascinating.
And so many different avenues that it's expanding out into, not just the common C++ applications, but you're seeing, it going into web contexts and all kinds of other things. It's really cool, the variety that you can get into with the programming language.
Absolutely.
All right. Well, thank you very much for joining me, Alex. I really appreciated having you along and loved hearing your input and the articles that you proposed. I really appreciate it.
I love being here. I really enjoy discussing all this with you as well. The articles it's great to talk in such depth with you about them.
Thanks. Well, I'll hopefully be able to have you back on again soon. And
excellent. I'd love that.
That's all for now. Thank you very, very much, everybody, and see you later.